So hopefully everybody ended up with the exact same thing that I had. So with this in mind, let's go ahead and start typing some stuff into the calculator. So again, we're going to let our observed matrix be L1, our expected matrix be L2. And again, I'm going to type them in that same order that I typed them before. So I'm going to go across and then to the next column from there. So with this one, we should have 8 entries total in our list 1 and our list 2. And again, we want to make sure we're going in the same direction for both of them. So let me pull up the calculator real quick so I can start typing these in. So stat, edit. So we go ahead and clear out these lists so I can reuse list 1 and list 2 again. So I've got 332, 318, 29, 27, and 1360, 104, 35, and 18. All right, and so now I want to type in the expected matrix in the exact same order. So 537.36, 134.02, 20.3, 14.3, 1154.64, 287.98, 43.67, and then finally 30.71. All right. So again, now that we've got everything typed in there, now we're ready to use that same command that we did before. So if we go back to the paper to calculate our test statistic, we're going to do chi-squared of t is the sum of our list 1 minus list 2 squared, all divided by list 2. And so if we put this in the calculator, so again, we'll hit second quit, second stat to go into list mode, math, sum, and then our parenthesis list 1 minus list 2 squared, all divided by list 2, gives us 503.29. See, I had a different value. Hold on, let me check here and see if I typed something in wrong real quick. So I had a different number. Hold on real fast. Let's see. Oh, there it was. So this should have been 104 instead of 107. Hopefully you guys caught that at home. 3518. All right, let's check this one. Oops. Hold on, lost it. All right, so the rest of those look good. So let's try this again. So second sum, enter. There we go. That's what I was expecting. So 507.1 looks to be our chi-squared sub t. I mean, they're both ridiculously big either way, but I wanted to make sure I had the right number of what I was expecting. So 507.1 is what we're going to get as our chi-squared sub t for this one. And so with this guy, since our alpha is not given, or it is given, so it's going to be 0.05. So we want to figure out what our chi-squared sub c is here. So we're going to have to use our table, but we do need to know our degrees of freedom. So since our rows is 2 and our columns is 4, then our degrees of freedom is going to be 1 times 3, which is just going to be 3. So if we flip back to our table, And so we've got our alpha of 0.05, so with the degrees of freedom of 3 is going to give us a 7.815 for our chi-squared comparison, so 7.815. There we go. Now, how does chi-squared sub t compare to this? So again, if we're in the shaded, we're going to reject h naught. If we're in the white, we're going to fail to reject h naught. And so 507.1 is probably going to be somewhere way even further to the right than that, technically. So it's going to be way, 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 way to the right. So we're definitely going to reject h naught in this case. So let's go ahead and figure out what our p-value is and compare this and hope it's the same. So we're going to get chi-squared CDF of our chi-squared sub t, so 507.1, comma, some ridiculously big number, comma, our degrees of freedom of 3. And so when we type this in the calculator, so second vars, chi-squared CDF, so 507.1, comma, some ridiculously big number, comma, our degrees of freedom. Like, it doesn't even mess around. No scientific notation, nothing. It's just straight 0. The probability of this happening is pretty much impossible. So with that being the case, this is 0, which is less than our 0.05. So we're clearly going to reject h naught. So these two variables then are dependent in this case. So the variables and so whether you survived or died definitely does make a difference in this case. So it does depend on whether you were a man, woman, boy, or a girl as to which category you actually fell into. So again, this is a super, super, super reject h naught for this one. So, all right. So again, hopefully everybody was able to follow that. Again, if you have any questions or anything like that, just let me know. So I've got some more practice problems I'm going to divide up amongst the groups. And so when you're finished with these, we'll talk about our last kind of hypothesis testing in this case, which is going to be what's called the test for homogeneity. So I'll see you in the next video. So good luck.